Hey guys, welcome to Flat Tutorials, and this is how to make a car game episode 4. And today we're gonna create a script that will gonna make this camera follow our car, and we're gonna make that script to make this camera zoom out a bit as the speed of this car increases. And yeah, and one more thing, when the car is gonna be reversed, the camera is gonna come in the front and chase the car from the front view. And yeah, so let's get started by creating a script. Name it car camera script. Now open it inside of your monodevelop or unisite. All right, now let's create a variable. Name it, let's say, what we have name it car, I guess. Car. There's going to be an of type transform variable, and then we're going to create another variable, name it distance. This is going to be an of type float variable. It's going to be equals to 6.4, and let's create a height variable. Height is going to be a float variable. Value is going to be 1.4. And then we're going to create another variable. We're going to name it as rotation damping. It's going to be equals to set to float, and be equals to 3.0. Then we're going to go over here and name it height damping. Height damping, which is going to be an up type float variable, and is equals to 3.0. Sorry, I'm going to make it 2.0. And then we're going to go another variable, name it zoom ratio. It's going to be also going to be a float variable, which is going to be set to I guess 0.5. Then we're going to create a private variable, which is going to be rotation vector variable. Rotation vector, and it's going to be an of type vector 3. So I'll explain it to you what these variables we're going to do in a minute, but first let's get into the coding. And function update, we're going to change this function update to function late update. Now why we did this, because function update can only be called once per frame, and function late update also can be called once per frame, but the function late update executes after the function update after the function update is done by its calculation. So if you want to make sure that the car is moved, then we're gonna calculate the position of the camera. So let's create a variable, name it wanted angle. And this is gonna be the car dot Euler angles dot y, end of the statement, and variable wanted height, which is going to be equals to car dot position dot y plus height. Then we're going to create another variable, my angle, which is going to be equals to transform dot Euler angles dot y, end of the statement. Then we're going to create another variable my height, which is going to be equals to transform dot position dot y, end of the statement. So what these variables are going to do is the function wanted angle, we're going to find the y-axis rotation angle of the car, and wanted height, we're going to find the position on the y-axis of the car and add the value of height onto that float, and then we're gonna we have this my angle. This is exactly the same of this, but and the my height, this is exactly this is also exactly the same, except we are not adding any value to it. Alright, so let's go and type my angle is equals to math math sorry math dot lerp angle, and we're gonna have a as a float, b as a float, and time as a float. So we're gonna take it as my angle, comma the angle that we want. So it's gonna be a wanted angle, and the time. So the time is gonna be rotation damping, rotation damping times time dot delta time and of the statement. So what this will gonna do, math f dot lerp angles means you are changing a value to a value with the speed of this. Okay, so we are smooth damping the value from this to this float value, and this will gonna make a smooth movement of the camera towards the car. Okay, so let's create another thing that we want. So let's go my height is equals to math f dot lerp let's say t as a float, so it's gonna be my height comma wanted height height damping DST height damping times time dot delta time, end of the statement. Alright, so this is exactly the same of this, except this one has mathf.lerp and this one has mathf.lerp angle. Now I use mathf.lerp angle because we are talking about rotation here, and here we are talking about just a float value. We are smooth damping. So this is better if we use mathf.lerp. Okay. Now let's find the rotation angle of it. So it's gonna be current rotation. Create a variable, name it $E and current rotation, and this is gonna be equals to quaternion dot let's say quaternion dot Euler 0, 0, 0. Alright, so I want to change the y-axis. Yeah, it's gonna be my angle and the statement. So this will gonna does, we're gonna find the quaternion angle on the y-axis of this is we're gonna put the quaternion we're gonna use a quaternion variable and put the y value of this my angle y value, which is lerping at every frame. Okay, now let's just what we're gonna do now, we have this. Alright, so we're gonna normalize the pollution. So it's gonna be transformed from that position is gonna be equals to car that position end of the statement. Then we're gonna go transform that position minus equals the current angle the current angle times vector 3 dot forward, and we're gonna times the to distance and the statement. Now what we have to do is to just look towards the car. So what we're gonna do, we're gonna go transform dot look at car. Now what this we're gonna does is we're gonna assign the value. We're gonna put the camera at the back of the car by adding distance value to it, and now this code what this code we're gonna does is we're gonna find the angle and the position of the car and adjust itself, and then at the end of this code, it will gonna look towards the car. So the camera is always gonna look towards the car and adjust its positions by the help of this code. Okay, so let's test it. Okay, current angle. C-R-E-N-T. Yeah, so current rotation. R-O-T-A-T-I-O-N, rotation. Now let's test it. Run it. Oh yeah, I didn't test it. So put this camera script onto your main camera and assign the car variable over here, and then hit on play, and let's see. I wanted to add some height to it. What the hell is going on? Height. Car that position at right plus height. Why it is not adding it? I guess I'm right. What's the problem? What the hell is going on? Oh yeah, I didn't add the. Oh my god. Transform dot position dot y is gonna be equals to my height. Yeah. All right. So the position of the camera on the y-axis will gonna be equals to the my height, which is lerping at every frame. Now let's test it. All right. Now you can see the camera is working. Now the problem is as the script as the value of this car's speed increases, the camera doesn't zoom out. So we're gonna create a script that we're gonna fix that thing, and already 12 minutes are gone. So let's get into it real fast. So function fixed update, and we're gonna and you know what function fixed update is about. All right, so let's see what we can do. We need to assign a zoom ratio to it. Okay, zoom ratio to it. Okay. So first thing is we're gonna calculate the speed of it. So a variable acceleration is gonna be equals to car dot rigid body. Dot rigid body. Dot rigid body. Dot velocity. Dot magnitude. End of the statement. Okay. Now we're gonna go. We're gonna create another variable. Variable default FOV. And this is going to be an of type float variable, and it is going to be set to 60 by my guess. And let's go to car.rigidbody.velocity.magnitude, and now let's adjust the FOV. So camera dot field of view is going to be default default FOV, default FOV plus the value we want, so it's going to be ACC multiplied to we'll say we're going to multiply it or not. Let's say multiplied to zoom ratio, and we're going to multiply it to time dot delta time, and let's check this out. Alright, now, oh whoa, the name float does not, whoa, oh yeah, float. Alright, now let's play this the thing, and now you can see as this speed will gonna increase, the FOV will gonna change, but I wanted to make it Oh, good. So, oh my god, the physics problem. Alright, so now you can adjust it. Let's say I wanted to adjust it about 5, I guess. Now you can see it's going back a bit. And as you slow down, we're gonna come in the front. So that's what we want. And now what we want is to make this camera go back as we're gonna reverse. So in order to do that, what you gotta do is to go here and make this Euler angle to what you need. Okay, so we're gonna go rotation vector. Okay, so let's just go over here. So what we need, let's say if we use the rotation vector. I don't think it's gonna work, but let's just try it. Okay, so let's create a variable car. Let's say local velocity. Velocity is gonna be equals to a car dot inverse transform direction is gonna be rigid body. Let's say car dot rigid body dot velocity dot magnitude and enter the statement. Okay, so let's create an if statement. If the velocity of this thing is let's say local velocity dot z. Yes, the spelling is right. Yeah, dot z. I think that if we didn't use the magnitude value, it's gonna work better. Okay, so let's just go over here. Dot z is smaller than minus 0.5. So we're gonna make it perfect, and let's just go over here. Our rotation vector is gonna be equals to let's say car dot Euler angle dot y plus 180. Okay, so if this will and by my guess this should work, and we're gonna create an else statement. Else we're gonna copy this thing. I'm gonna paste it right over here. End of the statement. Alright, oh my god, 18 minutes are gone. Okay, so rotation vector, Euler. Okay, now this should work, and change the rotation vector is gonna be over here. Change this wanted angle to rotation vector dot y. Okay, now what this means is the local velocity variable will gonna calculate the speed of the car onto the z-axis. If this car is going backward, it will gonna count that speed on minus, and if it's going in forward, it will gonna count in the positive value. So if it is below 0.5, then we're gonna turn the camera around by adding 180 degrees values to it. And if we doesn't have this value, then we're gonna use the normal axis. Okay, so now let's test it, and I hope that will gonna work. What? This cannot convert a vector 3 to a float. Oh yeah, rotation vector dot y. Okay, make sure you did this. Alright, I think I'm gonna fix it. Rotation x dot y. Okay, now let's just go over here, and now it's fixed. Now just save it. I know it will gonna work. Let's see. Okay, now you can see the camera is following the car, and when we gonna be reverse, the camera is gonna go back a bit. And let's just speed. Alright guys, I'm sorry about that problem. of the video recording. Now let's see. I can see now change one more thing inside of the script. Just zoom ratio, take it as zoom ratio, delete the timestamp dot delta time, and now test it again. You can see this is working pretty good. Now let's reverse it. I can see camera is working. So that's all for this tutorial, guys. And if you like this tutorial, you can subscribe me. If you have any problems, you can always leave the problems in the comment under this video. And yeah, so goodbye and do all that good stuff. Subscribe to me, like this video, and yeah, all of you guys, and goodbye.